Okay, so let me just check. Okay, sorry. So I also did Module 5, Chapter 12. The question was 24. I'm going to read it out loud. So the sample space, 2. For each of the following, list the sample space and tell whether you think the events are equally likely. So A is roll 2 dice and record the sum of the numbers. So I said the sample space is 2 to 12 because since there's 2 dice with 6 sides, the lowest you can get is 2 and the highest you can get is 12. So the sample space would be 2 through 12. And I said, no, it is not equally likely. You have more chances to roll everything other than 2 and 12. Now let me explain why. So to roll a 2, you need just 1 and 1. So say you roll a 3, then one dice could have a 2, one dice could have a 1, and then vice versa. The other dice could have a 1, the other dice can have a 2. But say you roll to get a 2, then there's just one option, which, so there's just one option. So basically there's technically a 1 in 36 chance, there's more opportunities for the numbers not being 2 and 12, so it can't be equally as likely if the opportunities aren't all the same. And that is, again, it just because if you roll a 1 on one dice and a 1 on the other dice, you can't do vice versa. It's the same thing. But if you are getting a 3, if you roll a 1 on one die and a 2 on the other die, and then you can switch it so you can roll a 2 on one die and a 1 on the other die, and that gives you a higher chance of rolling those numbers than 2 and 12. Okay, I hope that made sense. There's more opportunities, basically. So it's not equally the same. Not equally likely. Okay, so B, a family has 3 children. Record each child's sex and order of birth. So what I did, the sample space, there is 1, 2, 3, 4, 5, 6, 7, 8 different combinations, and I just did 3 combinations of males and female. So the first one is male, 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 then female, 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 then male, male, female, male, female, female, male, female, male, female, male, female, female, male, male, female, female, male. And it is equally likely there is a 50% chance in having a boy or a girl, but there are 8 different combinations. So it is equally likely since it is a 50% chance in having a girl or boy. That is a proven fact. So it is equally likely, but there are 8 different, so basically 1 in 8th chance of getting these combinations. Okay, C. Toss 4 coins, record the number of tails. So the sample space is 0 through 4. Because technically you can get, if you're tossing the coin 4 times, you have a 50% chance of getting tails every time. So you can either get 0 tails or you can get 4 tails. So that is why my sample space is 0 through 4. So yeah, you can either get no tails or 4 tails or any integer in between. It's equally likely because every coin flip is a 50% chance. It's 50% to get head or tail. No matter what we do, we'll get either heads or tails. That's why it is equally likely it'll always be 50% of a chance if you're looking for the number of heads or tails. Just because there's 2 options, it's 50%. So the next one is different. Toss a coin 10 times and record the length of the longest run of heads. This one is saying when you toss a coin 10 times, you have to record in a row the longest run of heads. So basically saying, like, in a row I can get 5 amounts of heads or I can get 2 amounts of head. So basically it is not equally likely. There's a 0.5 to the 10th percent chance of getting all heads in a row, which is very low. Not equally likely. It's easier to get 2 heads in a row than to get all 10 heads in a row. So the higher you get the heads in a row, the less likely it is to get heads in a row, which means it's equally not as likely. So if you think of it this way, if you toss a coin, you might get heads 3 times in a row. That might work, but it is very unlikely to get heads every 10 times. So it is not equally as likely. So I hope you guys understand the differences. If you guys have any questions, please let me know. Thanks.